Hello viewers, welcome to Elimu TV, a place where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 4, lesson number 35. And our title is Radioactivity. The objectives of this lesson are to investigate the effects of radioactivity. We have an atomic structure. As you can see, an atom is made up of electrons, neutrons, and protons. The nucleus of an atom has a specific number of protons and neutrons. The number of protons in the nucleus is called the atomic or proton number, while the sum of the number of protons and neutrons is called the mass or the nucleon number. If an atom X has atomic number Z with n neutrons and mass number A, it can be represented as where A is equals to Z plus N. Some atoms have atomic number but different mass numbers. Such atoms are said to be isotopes. For example, carbon 12 and carbon 14 are isotopes of carbon. Next. As you can see there, the atomic number is on the upper part, the atomic number is on the lower part, and the mass number is on the upper part. And the mass number is the number of protons plus neutrons, and the atomic number is the number of protons, which is also equivalent to the number of electrons. Isotopes are atoms of the same element that have the same number of protons but different number of neutrons. This results in different atomic masses. As you can see, helium has an isotope, hydrogen has an isotope, and also lithium. Next, we have factors affecting radiation. We have nuclear stability. Stable nucleides have a proton to neutron ratio of 1 to 1. However, as atoms get heavier, there is a marked deviation from the ratio, with the number of neutrons fast as superseding that of protons. In such circumstances, the nucleus is likely to be unstable. When this happens, the nucleus is likely to disintegrate in an attempt to achieve stability. You can see from the graph the number of neutrons drawn against the number of protons for non-stable and unstable nucleus. From the graph, it is observed that the unstable nucleides are outside the stability line. You can see the stability line there, the straight line there, that is called the stability line. Those nucleides have above the stability line have too many neutrons, hence decay in such a way that the protons number decreases. And those below the stability line have too many protons and therefore decay in such a way that their proton number decreases. Next, we have the types of radiation. We have types of radiation. Radiations are emitted by radioactive elements. As you can see, we have various radioactive elements like radium. Radium is a radioactive element. So, what is radioactivity? It is the spontaneous random emission of particles from the nucleus of an unstable nuclei. It is the spontaneous random emission of particles from the nucleus of an unstable nuclei. And we have various types of radiation, which include alpha decay, beta, and gamma radiation. In alpha decay, if the nuclei decays by release of an alpha particle, the mass number decreases by 4 and the atomic number by 2. This is expressed, as you can see there, we have the radium, whereby the mass number 226 decreases by 4 and it becomes 222, and the atomic number decreases by 2. From 88 it comes to 86. Next we have the beta decay. In beta decay, if the nuclei decays by release of a beta particle, the mass number remains the same, but the atomic number increases by 1. As you can see there, the mass number of hydrogen H remains the same, but the atomic number increases by 1. Next we have gamma radiation. Some nucleids might be in an excited state, and to achieve stability, they may emit energy in form of gamma radiation without producing new isotopes. As you can see, that is an example of gamma radiation. So, what is penetrative power? Penetrative power of radioactive radiations can be determined by first placing a radioactive source a few centimeters away from a radioactive detector. As you can see, we have alpha, beta, and gamma. Gamma rays have more penetrative power. As you can see, they are able to penetrate and move for a longer distance, and also they can able to penetrate lead, which is a very heavy substance. And beta rays have lesser penetrative power as compared to gamma rays, while alpha rays have low penetrative power. The least they can penetrate is a paper. They cannot go past that. Next we have the ionizing effect of radiation. When alpha, beta, or gamma radiations pass through air, they knock off electrons from air molecules, resulting in the formation of positive ions. This effect is called ionization. Since an alpha particle is heavy and slow, it takes quite some time to pass through air. As you can see, the alpha particle takes some time, a long time to pass through air. It is therefore able to knock off more electrons from beta particles and gamma rays, which are light and fast. And that is the end of our lesson. I have questions for you. Number one, between alpha rays and beta rays, which ones have a high ionization effect? Number two, between gamma and alpha rays, which one has a high penetrating power? Our reference book comes from the book of KLB, Book 4, Physics, 5th edition, 2019. For more information, you can contact us on our phone number, on YouTube at Elimu TV, on Facebook Elimu TV, and on Twitter at Elimu TV_KE. Thank you for watching Elimu.